number 4 and 5 in the bell work here have a lot to do with what we're going to be doing in our lesson today. Okay? Number 2 and number 3 that we've just looked at here, both are pretty simple to factor because there's only one choice for x squared. That's x times x. So you just have to find the factors of negative 10 that add up to be positive 3. Find the factors of negative 42 that add up to be negative 1. And that's the values that go in these two blanks. So these trinomials where the leading coefficient is 1 are really simple to factor. Okay? We want those kind. But what we're doing in 4 and 5 is multiplying things together. And we're not going to get 1x squared when we multiply these together, are we? No. What are we going to get?
12x squared.
We're going to get 12x squared.
7x minus 10.
All right, that's minus 8x plus 15x, right?
Right, which is 7x.
It's going to be 7x, and 5 times negative 2 is negative 10. So this is 12x squared plus 7x minus 10. Okay? 2x plus 5 squared is 2x plus 5 times 2x plus 5, right? Which gives us, let's do the process, 4x squared plus 10x plus 10x plus 25. Okay, so that gives us, in the simplified form, 4x squared plus 10x plus 25. Okay?
20x.
I'm sorry, 20x. Now, the key to understanding the process that we're going to look at today, guys, is to be able to do this backwards. So we want to break this back down into its pieces and then use the pieces to go back to factored form. Okay? So what we mean by pieces is this was 12x squared minus 8x plus 15x minus 10, and we took those two pieces and made them into 7x, which is correct. And then we took 10x and 10x and turned those into 20x. So we're looking for a pattern. There's a pattern here, but it's not as simple as finding the factors of negative 42 that add up to be negative 1. Right? The pattern is not that simple. Now, I'm going to tell you that the pattern has something to do with these terms in both instances. So play around and see if you see anything there. Think about if you see any relationships between negative 8x and positive 15x and this, because we're going to be working today and factoring this into this and then that back into that. We're going backwards.
Oh, fun.
So how would we know that 7x needs to break down into negative 8x plus 15x? Because there's lots of choices, right? Lots of choices, 6x, 1x, 10x, 3x. Lots of things add up to be 7x. How would we know it's got to be negative 8 and positive 15? Liam.
Since negative 10 is negative, then one of the factors has to be negative.
Okay, we know that. We're going to have to be dealing with some negatives to get that negative 10. That's a good observation. What else? Do what? Yes, we're always going to make that term positive. Even if we have to factor out a negative 1, we're going to make it positive. Well, what's the relationship between negative 8 and 15 and something in our original polynomial there? Let me ask you this question.
Oh, the first and the...
First and the what?
4 and 2 and then 5 and 3.
Oh, yeah.
Well, I know that's where they actually come from, right?
Yeah.
But what's negative 8? I'm talking about this.
Oh.
We're looking for a pattern because our problems today are going to look like this and our answers are going to look like this. We're working backwards. Okay? So what is the relationship between our original problem and this 8 and 15 here? What is negative 8 times 15?
Oh, what? Is it 120?
It is negative 120. Right? Do you see anything else on here that would multiply to be negative? 12 times negative 10 is also
That's awesome.
negative 120, right?
I need to write this down.
All right. Oh, we'll get it in just a second. Now, let's go back over to this one. What is 10 times 10? 100. What is 4 times 25? 100. Okay, so we're always going to be looking for the factors of this number. Factors of 100 that add up to be 20 are 10 and 10. The factors of negative 120 that add up to be 7 are negative 8 and positive 15. Okay, so that pattern is always going to work, and I know right now this is a kind of a scribbled up mess, but that's how the process is going to work. All right, so today we're factoring trinomials with a leading coefficient other than 1. All right, now we haven't really given it this name yet, but I want to give this a name. We talked about it in lesson 71 maybe, where we have ax squared plus bx plus c. Okay, this is the standard form of a quadratic, what we call a quadratic polynomial. This is a new definition, right? Quadratic polynomial is ax squared plus bx plus c. And we had a problem, that said, what are the values of c? How many possible values of c are there, or values of b are there? Y'all remember that homework problem? I think it was 36, and there was 10. 10 or something was the answer. But ax squared plus bx plus c is standard form of what we call, a quadratic trinomial. Now, this quadratic trinomial, is kind of the foundation for everything. Remember, we're working our way up, right? What is algebra? The branch of mathematics where we learn the skills necessary to solve all types of equations, right? And we're working toward being able to find all 5 solutions to a 5th degree polynomial, all 6 solutions to a 6th degree polynomial. But the building blocks is we solve our 1st degree equations, right? Just regular old linear equations. Then we're going to solve 2nd degree equations. Those are quadratics. And that's as far as we're going to get in Algebra 1. Algebra 2 and Algebra 3, pre-cal, you'll get into solving the higher orders. But every 5th degree polynomial at some point is going to have a quadratic that's part of it that you have to solve. So we're building the skills that we're going to use later. That's why this is so important and so foundational. And factoring is one of the methods that you will use to solve quadratic equations. And so the skill is important. All right, factor completely. 2x squared plus 7x plus 5. Now, this one is easy enough to just play around with. We don't have to get real technical with the process that I just showed you, because the first number is prime, right? So are there any other options for these first 2 terms? They have to be what? 2x and x, right? That gives us 2x squared. And then these 2 terms are going to multiply to be positive 5. I don't have a whole lot of choices there, do I? It's 5 and 1, so this is either going to be 1 and 5. Will that work? How would we check to see if that would work? Yeah, we'll do these inside and outside terms. That's 10x plus 1x. That's not 7x, right? And so that process or that combination of factors is not going to work. We can't use 1 and 5 in that way, which means we are forced to use 5 and 1 in this way. Okay, 5 and 1 in that way will give us 2x plus 5x, which is 7x. And that means that this is a good factorization of what we started with. No. The order's not important. It could be x plus 1 and 2x plus 5. We still get everything's the same. Okay, so that one's easy enough to figure out without really going through the process that we're going to use. what that process is going to look like is this. So I'm going to back it all the way out here and just kind of erase things. Here's what the process is going to look like. We are going to start with a pair of parentheses because we know that if this is factorable, that's what it's going to look like, right? This times this is going to be 2x squared, and hopefully this times this will end up being positive 5. And these two products have to add up to be 7x, right? Here's how you find those factors. What is 2 times 5? 10. What are the factors of 10 that add up to be 7? 5 and 2. Okay, so 2 and 5. So these two terms have to be 2x plus 5x. You with me? Mm-hmm. Now, we don't have any choice for what goes in our front of our, that has to be 2x and x, because 2x squared is 2's prime, and that's the only way you can get 2x squared is 2x and x. All right, so 2x is going to multiply by something over here to give me one of these numbers. Which number does it have to be? Can we multiply 2 by something to get 5?
No.
Not as integers anyway, and these will always be integers. 2 times 1 then will give us the positive 2x, positive 1, right? And then x times 5 will give us positive 5x, and that's how we're going to work it. So it's like a puzzle. We're unfoiling it. We're working the process in reverse. It always starts with our framework, the two binomials, and multiplying the leading coefficient by the constant to find this number, and then find the factors that add up to be that number. Those go here, and then you fill in the puzzle, make it work. Okay? Let's look at another one. 6x squared minus 11x plus 3. Now, immediately, we see that this one's going to be a little bit more complicated because 6 is not prime. It's a composite number, so I've got choices already, 6x and x or 2x and 3x. The number that we're going to use is going to be dictated by the two numbers that come right here, these two products, right? So we start by multiplying 6 times 3, and what do we get? What are the factors of positive 18 that add up to be negative 11?
9 and 2.
Both have to be negative. So negative 9 and negative 2, that tells me that these two products, this times this, those two products have to be negative 9x and negative 2x to get negative 11x. Okay? Now that we know those two, we can make an educated decision about what goes in those two slots to multiply to be 6x squared. What does it have to be? Can we use 6x and x? No, because 6 can't be multiplied by an integer to get 9 or 2. So we have to use 2x and 3x, or 2x and 3x. It doesn't matter what order you put them in. 2x multiplies over here, not to get 9, because that's not possible. Multiplies to get negative 2s. That means this has to be negative 1.
And negative 3.
Then 3x times negative 3 would give us negative 9. Okay? Now, that would give us 6x squared. And the final check, negative 3 times negative 1, positive 3, and everything checks out, right? I got 6x squared. I got negative 11x. And I've got positive 3. That is the correct factorization of 6x squared minus 11x plus 3. Then you need to do this a lot, this process. This, more than anything we've done all semester, the process is important. You're going to get shown some shortcuts later in your mathematical life. Don't use them. They work about 90% of the time, and that's not good enough for honors math. You need to know how to do this way, because this works 100% of the time. Okay? All right, let's have a look at another one. 4x squared plus 4x minus 3. All right? This is going to factor to a pair of binomials, right?
I got it.
What's 4 times negative 3?
Negative 7.
Negative 12.
Negative 12.
And what are the factors of negative 12 that add up to be positive 4?
6 and negative 2.
6 and negative 2. What does that give me? That tells me that these two products have to be 6x minus 2x. All right? Now that is going to help me pick these two factors. Could I use 4x and x? Why not? Because you can't multiply 4 times an integer to get 6 or 2. It's not useful to us, which means we have to use 2x and 2x. So we can multiply this 2x by this term over here and get either one of them. Negative 1 to get the negative 2x. And then that leaves me 6x, so I have to do plus 3 here. That's 4x squared. And what's 3 times negative 1? Negative 3. So everything falls right into place. Now I want you to notice that we did that factorization without ever even considering this term, other than multiplying it by 4. But that term is always going to be correct if you factor it correctly. If you don't factor it correctly, that term's not going to be correct. Or that product won't work. All right? And this always ends up with our, and we've kind of been joking about this guy all year, you know,
Oh my gosh.
toothless polynomial Bob, or whatever you want to call him. Big-eyed Bob. I did this with a red pen a few years ago, and my students called it Bob the Tomato. Remember Bob the Tomato?
Yes.
It does kind of look like Bob the Tomato. When he, if it were red, it would. All right, next one. 3x squared minus 11x minus 4. 3x squared minus 11x minus 4. We want to factor this into a product of binomials if it will factor, right? 3 times negative 4 is negative 12. Now, here's where you determine whether it's factorable or not. If we can't find any factors of that product that add up to be the middle term, then it's not factorable. All right? But you got to make sure that you've checked every possible factor pair before you make that determination. All right? Are there any factors of negative 12 that add up to be negative 11? What are they? Negative 12 and positive 1, which means these two terms are going, or these two products have to be negative 12x and plus x, plus 1x. Now this one's pretty easy because we don't have any choice for 3x squared except for 3x and x, right? So that's the only way I can get my 3x squared. What's going to go over here in the second? Negative 4, right? That'll give me the negative 12x. And then this has to be plus 1, right? That gives me that plus x. What's 1 times negative 4? Negative 4. And see, we never considered this number. It just works. It's going to happen. It's kind of magic. Let's give him eyelashes this time.
Good nostrils.
Nostrils right here.
Yeah, perfect. That looks like Sid the Science Kid or something.
Yeah.
Sid the Science Kid.
On the side.
Okay. All right.
Oh, there's a Y.
Now, what did we do with y's when there was x and y in the... We're going to ignore it till the end. And as I told you then, I'll tell you now, other than the just practicing the factoring skill, there's no practical application for the x and y in the same expression. You know? So we would... Binomial times binomial, right?
And it has to be 2x and x.
It has to be 2x and x. So it's okay to go ahead and write that if you want to. 2 times 5 is positive 10. What are the factors of positive 10 that add up to be negative 11? Negative 10, negative 1, which means these two factors or these two products have to be negative 10x minus x. So then it becomes pretty clear what to do from there, right? 2x times what? Negative 5. That'll give us the negative 10x. And then x times negative 1 will give us the negative x. And then we just throw the y in there as icing on the cake. Yes, you could just say negative y. Now, that's 2x squared, and let's do this final check. That would give us plus 5y squared, so we're in good shape. Just a couple more. Couple more. Okay. Actually, 3 more. Now, these are a little different, but right? Pretty easy though. What do you have to do? We're going to put them in standard form, right? We want to put them in descending powers of x. So the first example, A here, will be 12x squared minus 17x plus 5. Start with our binomial times binomial because that's what we're looking for. And I'm going to multiply 12 times 5, and that's going to give me 60. What are the factors of 60 that add up to be negative 17?
Okay. Well, this is going to take a minute.
What?
I was going to say 12 times 5, but that's not, I mean 12 times 5, that's
Sure it is.
12 and 5, yeah.
Yeah, negative 12 and negative 5. That means that these two products have to be negative 12x and negative 5x. Okay? And that's going to help me pick the factors. Now, we got lots of choices for 12, right? 2 and 6, 3 and 4, 1 and 12. 2 and 6 won't work because I can't get 5 from 2 or 6. 3 and 4 won't work because I can't get 5 from 3 or 4. It has to be just 12x and 1x, right? So that's how that decision-making process takes place. We're going to use these two numbers to determine which factors of this number to use in our parentheses. So 12x will have to multiply by what over here? Negative 1. And then this has to multiply by negative 5. And negative 5 times negative 1 is positive 5. We won, right? So 12x minus 5 times x minus 1.
You said that you don't use the last term. Like, I do use the last term before I actually think about the...
You can do that. I'm just telling you that you really don't even have to consider it. If you pick the correct factors for this number to get these correct factors, that one is always going to work. You really don't even have to think about what that is because this number is incorporated when you multiply these two things together. So we are considering it because it's part of the product that we're working with to begin with. All right, I think I see some of you have already started this one, right? So 4x squared minus 7x minus 2. 4 times negative 8. 4 times negative 2 is negative 8. What are the factors of negative 8 that add to be negative 7? Negative 8 and positive 1, which means these two middle term factors are negative 8x plus x. Okay? Now, can we use 2 and 2 to get 8 and 1? What do we have to use for 4x squared? You have to use 4x and x. Now, let's go back. All right, you picked 2 and 2.
It doesn't work.
It doesn't work. And I just want to show you what trial and error might look like. 2x times
4.
positive 4, negative 4 over here would work, right? But then what are you going to multiply 2x by to get x? Yeah, it doesn't work. Okay? So that's not good. So 2x and 2x is no bueno. Can't use it. All right? That means we have to use 4x and x, and this will work. 4x times negative 2, x times positive 1. That's, of course, 4x squared. 1 times negative 2 is negative 2, and we are golden. How are you messing it up?
No, I wrote the wrong one for wrong term.
Y'all, this is a foolproof process. You think your way through it, okay? Let's do one more. This is the last example that's written here, but let me give you one to work. Maybe one that has a few more options. Let's do 6x squared minus 13x minus 8. All right. All right, what do we do first? 6 times negative 8 is negative 48. She said 16 and negative 3. Is that right?
I don't know.
Yeah, I haven't got that far yet.
Oh, my bad. I meant negative 16
Yeah.
and 3.
Yeah, 3 times 16, and this is a popular factor pair of 48, y'all. I know y'all are, when you see 48, everybody quickly says 6 and 8 and 4 and 12. You forget about 3 and 16, right? Remember, 48 is 16 times 3. Okay, so because it's used a lot. And that means that these two products in the FOIL process have to be negative 16x and positive 3x. Now what are we going to use here to get 6x squared based on?
3 and 2.
It would have to be 3 and 2, right? 6 wouldn't work. We can't get 16 or 3 from 6x, so it's got to be 2x and 3x. What's this 2x going to multiply by over here?
Negative 8.
Negative 8.
Negative 8 and then...
And this 3x is going to multiply by
Positive 1.
plus 1, and what's 1 times negative 8? Negative 8, so I'm good, right?
Yeah.
So 2x plus 1 times 3x minus 8.
This is so much fun. Is that it? This is really
Yeah,
fun.
it really is. It's like a puzzle. If you kind of see what you're doing, you're unwrapping this thing, and you also get to make this goofy guy anytime you want to. Right.
That's the nose.
Yeah,
You just put teeth on the nose.
No, here's the nose right here.
Right there.
No.
That's the nose.
Yeah.
Yes.
Okay, I've been looking at it wrong the whole time.
Me too. I thought the very bottom one was his mouth.
That's the whole
yeah.
face.
That's
That's
no,
the
but
face.
but then his eyes are big as his face. Oh.
That's exactly. He has glasses on.
He's polynomial man.
Yeah, do no question.
All right,
He's like Gallon guy.
here's your homework.